Carnot cycle and their process. These are the Carnot cycle adiabatic process. Adiabatic compression is the first process. The substance begins at a location A with a temperatures of T2. A with a temperatures of T2. The cylinder is placed on this stand and the substance is compressed by increasing the downward force on the piston. Downward position on the pistons. Since the cylinder is insulated, no heat cannot be transferred or leave the substance contained inside. Thus, the substance undergoes adiabatic compression and at the temperatures T1 to T2. Temperature increases to T1. Adiabatic compression T1 isothermal, T2 also isothermal. There is no changes. Adiabatic compressions Q equal to internal energy del U plus work done. Q AB equal to 0. Del UAB equal to CV, constant value T equal to T1 minus T2. So then AB equal to minus del U AB, W work done AB equal to minus CV into T1 minus T2. Adiabatic expansion isothermal expansion. The cylinder is now placed on the warm reservoir. A quantity of heat Q1 is extracted from the warm reservoir and thus absorbed by the substance. During this process, the substance expands isothermally T1 to location C, that means T2. During this process, the substance does work by expanding against the force applied to the piston. So these are the isothermal expansions. Heat supply Q equal to del U plus W, temperature T equal to 0, QBC, Q1, del UBC equal to 0, W equal to WBC equal to RD, T1 in VC by VB. Next one is a adiabatic expansion. The cylinder is returned to the stand. Since the cylinder now insulated, no heat can enter or leave the substance contained inside. Thus the cylinder undergoes adiabatic expansion until the temperatures return to T2. Location D. Again the cylinder does work against the force applied to the piston. Adiabatic expansion Q equal to del U plus W, Q CD equal to 0, CD equal to CV, T2 minus T1. So WCD equal to minus CV, T2 minus T1. Next one is a isothermal compression. The cylinder is now placed on the cold reservoir. A force is applied to the piston and the substance undergo the isothermal compressions to its original state location A. During this process, substance gives up the resulting compression heating Q2 to cold reservoir, allowing the process to occur isothermal. These are the examples of isothermal compression process. The result of isothermal compressions Q equal to del U plus W, WdA equal to RD T2 in VA divided by VT. Carnot isolated heat engines.